Today is our second lesson, and we are going to look at factors, multiples, and prime factorization. So let's start off with factors. So if I want to express 28 as a product of two natural numbers, well, the word product is just talking about multiplying numbers. So I want to look at two numbers that multiply to get to 28. A natural number is a positive number that is not a decimal or a fraction and does not include 0. So a really easy one, 1 multiplied by 28. Now we can get more complicated. 2 multiplied by 14 is also equal to 28, and 4 multiplied by 7 is equal to 28. So we can say 28 can be exactly divided by 1, 2, 4, 7, 14, and 28. And if we're asked to list the factors of 28, the factors of 28 are 1, 2, 4, 7, 14, and 28. Let's do another example. Let's list the factors of 36. So you might want to list out the numbers and cross them off as you go. You might know a few of them off the top of your head. Sometimes we lose them or forget them. And so one of the ways that I like to do it is I will do a factor tree for 36. I know 36 is divisible by 2, and 36 divided by 2 is 18. 18 divided by 2 is 9, and 9 divided by 3 is 3. Now I can look at the different combinations, so I can build the list of factors for 36. Well, every number is divisible by 1. Right away we can see 36 is divisible by 2. I can also use this combination. 4 times 9 is 36. Erase that quickly so I can have a little bit of a better view. And then 6. 6 times 6 is 36. Okay. 9 times 4 is 36. I can create in here a 12. 12 times 3 is 36. I can also create 18. 18 times 2 is 36. And finally, my last factor is going to be 36 itself. If that felt a little bit weird, that's okay. We're going to do some practice in class as well. Okay, so let's talk about the divisibility tests itself. So a number is divisible by 2 if its one digit is even. So some examples would be 4, 12, 2004. A number is divisible by 3 if the sum of the numbers is divisible by 3. Well, what does that mean? Let's do an example. So if I have the number 123, and I want to know if 123 is divisible by 3. If I add 1 plus 2 plus 3, I get 6. And 6 is divisible by 3. So I know that 123 will be divisible by 3, and I can just do long division on it. So 123 divided by 3. 3 goes into 12 4 times. 12 minus 12 is 0. I drop down my 3. 3 goes into 3 1 time. So my answer is going to be 41. Sorry, that got a little bit messy. Let's do one more example. Maybe I'll do it over here. So what about if I want to know if 471 is divisible by 3? Well, I'm going to add up all the numbers. So 4 plus 7 plus 1, this is going to equal 12. And 12 is divisible by 3. So I know that 471 will divide nicely by 3. So I know that 471 can be nicely divided by 3. So 471 divided by 3. 3 goes into 4 1 time. When I subtract that, I'm left with 1 remainder, and I'm going to pop down my 7. 3 goes into 17 5 times at 15, and when I subtract that, I get 2, and I'm going to pop my 1 down, and 3 goes into 21 7 times. So I know that my answer to 471 divided by 3 is equal to 157. All right, great examples. Is a number All right, next rule. A number is divisible by 5 if its one digit is a 5 or a 0. So some examples. 15 is divisible by 5. 1,000 is divisible by 5. 305 is divisible by 5. Oops. All right, last divisibility rule. A number is divisible by 10 if its one's digit is a 0. So, i.e., the last digit is a 0. So 10 is divisible by 10, of course. 1,000, 3,000, etc. All right. Now we need to look at what is a multiple. So 28 is called a multiple of 4 and 7. The first few multiples of 4, so the first one would be 4 times 1 is 4. 4 multiplied by 2 is 8. 4 multiplied by 3 is 12. 4 multiplied by 4 is 16. All right, so let's look at some relationships here, because we've been talking about multiples and factors so far. So if we're looking at the relationship between 28 and 47, if we're looking at the relationship If we're looking at the relationship 28 is equal to 4 multiplied by 7, then 4 is a factor of 28. 28 is a multiple of 4. 4 times 7 is 28. 7 is a factor of 28, and 28 is a multiple of 7. All right, last little bit here. Prime factorization. 60 we call a composite number. And 60 can be written as 6 multiplied by 2 multiplied by 3 multiplied by 5. Maybe we should check that. Well, 2 times 2 is 4 times 3 times 5. And 4 times 3 is 12 times 5. And 5 times 5 is 60. So we're good. We've broken it down. When 60 is written as only a product, remember product is just multiplying, of prime numbers, we call this a prime factorization. So what we've done up here is we've broken it down so that it's only prime numbers. It's 2 multiplied by 2 multiplied by 3 multiplied by 5. We call this a prime factorization. All right, let's do an example. Write 504 as a prime factorization and give your answer in exponential form. So you might want to do the tree method, you might want to do the step ladder. Either one gets you to the same answer. I like the tree method, so I'm going to do the tree. 504 divided by 2 is 252. If you're not sure, check it with long division. 552 is divisible by 2. That last digit is even, and we're going to get 126. It's going to be divisible by 2 again because this last number here is even. So we've got 2 and we get 63. Now it's not divisible by 2 anymore. The last number is odd. But if I add 6 plus 3 together, I get 9. And 9 is divisible by 3. So I know 63 is divisible by 3. And in fact, it's divisible by 3. And in fact, when divided by 3, we get 21. And again, notice 2 plus 1 is 3, so 21 is also divisible by 3, and that equals 7. So my tree is beautiful, but it's asking me to write it as a prime factorization in exponential form. So I'm going to start off with writing it in expanded form. So this is expanded form. Now it's asking me for exponential form, so I have 504, and I'm multiplying 2 by itself. 1, 2, 3. So I'm going to write that as 2 to the power of 3. 3 is being multiplied by itself twice, so I'm going to write that as 3 squared, or 3 to the power of 2. And I've got multiplied by 7 at the end. And this is what we call exponential. You might also see it as index form. Now, on your own, what I would like you to do is I would like you to write all of the prime numbers up to 27. So I've given you a list of instructions. Follow the instructions, and when you come in tomorrow, let's talk about which numbers are prime. And we're done.